Okay, so today we're going to be learning about working with ratio, and this is just going to be an introduction into ratios. So, let's get my pen set up. Get rid of that. Now, ratio can often be something that people have problems with, and a tip to think about of ratios, think of it as like a scaling exercise. So when you scale up or down, so say you were going to be doing a recipe, and the recipe is written for 4 people, okay? So all the quantities in the recipe are designed to feed 4 people, but you need the recipe for 10 people. What we can do is do 10 divided by 4, which gives 2.5, and this is a scale factor. So say the recipe wanted 500 grams of flour. You would times the 500 grams of flour by 2.5 to find out how many grams of flour you would need for 10 people. It's a scaling factor. I'll show you how this works in an example. So here's a recipe. Oops, I cannot spell recipe. For pancakes. So flour is 100 grams. Baking powder, 1 teaspoon. The milk is 150 mils, and eggs 3. And this serves 4 people. We want to cook for 6 people. So we think of our scaling factor, so we'll take the number of people we want to cook for, which is 6, divide it by 4, which is 1.5, and now we're going to rewrite our quantities. So we get rid of this bit here, and we'll rewrite our quantities down here. So number 6 divided by 4 is 1.5. So the 100 grams of flour times 1.5 is going to be 150 grams. The 1 teaspoonful is going to be 1.5 teaspoonfuls. The 150 mils of milk times 1.5, so times 1.5, remember we're timesing 1.5 each time, is going to be 225 mils, and the 3 eggs times 1.5 is going to be 4.5, but we can do half an egg, so we're going to round up to 5 eggs. Because you always need a whole number of eggs. Let's try another example. So a concrete mix. It's 1 part cement, 2 parts sand, and 4 parts gravel. A builder has 0.6 meters cubed of sand to use. Oops. So we need to calculate the amount of other ingredients. So let's put this in the way you would. So we've got the cement, we've got sand, and we've got gravel. So it's 1 part cement, 2 parts sand, and 4 parts gravel. And we know we have 0.6 meters cubed of the sand. Now let's think. We can take the same principle of the scaling factor. So we know how much sand we have. So we've got 0.6 and we're going to divide it by 2. So that gives us 0.3. Oops. So our 1 part cement, so it's going to be 1 times 0.3 equals 0.3. And for our sand, our gravel, we're going to have 4 times 0.3, which equals 1.2 meters cubed. What is the total volume of concrete mixed? So we're just going to add these 3 volumes together. So 0.3 add 0.6 add 1.2 equals 2.1 meters cubed. In the example above, the concrete was combined in 1.1 to 2 to 4. So this here is the standard notation for writing ratios, and it acts very much like a fraction, and we can think of ratios in the same way that we would a fraction. So we're going to do simplifying ratios, i.e. putting into simplest terms. And it's the same principle as ratio. So say we've got a ratio of 14 to 21. 14, 21 in the 7 times table, so divide both sides by 7. That gives us a ratio of 2 to 3. We have a ratio of 72 to 108. We can divide both by 12. And then we're going to get 6 to 9. And again, that can be divided down by 3, which leads us to a ratio of 2 to 3. And finally, we have a ratio of 15 to 25 to 45, and we're going to divide it by in the 5 times table, that's 4. 5 times table, so that's going to give us 3 to 5 to 9, because 15 divided by 5 is 3, 25 divided by 5 is 5, 45 divided by 5 is 9. And that's a simple introduction to ratio.